A dilation is a transformation that changes the size of an object. It makes a figure bigger or smaller, but it doesn't change the shape of the figure. It creates a figure that is similar to the original one, not congruent because it does change size. For this reason, a dilation is not a rigid motion. As you can see here, we have a pre-image, and the image of this triangle is bigger than the original. We say it was dilated by a scale factor, and to make it bigger, the scale factor had to be greater than 1. Usually you'll see K representing scale factor. So here we have a scale factor that's greater than 1, and we call this an enlargement. Notice how we have our center of dilation, O, and the pre-image point and the image point are double the distance from the center of dilation. Once again, the distance from the center of dilation to the pre-image point is doubled to get to the image point. So when we make a figure bigger, we move it away from the center of dilation. Over here, we have that we're going from a bigger pre-image to a smaller image. So here, the scale factor has to be less than 1. And we call this a reduction. And notice here how the distance from the pre-image point to the center of dilation decreased. The image point to the center of dilation is less than the pre-image point to the center of dilation. So in order to make a figure smaller, we move it closer to the center of dilation. So if you're making it larger, it moves further away from the center. And if you're making it smaller, it gets closer to the center of dilation. Over here, take a second and try to determine if the scale factor K in each of these situations is greater than 1 or less than 1. Over here, the scale factor is greater than 1 because from the pre-image to the image, we're getting larger. Here, the scale factor K is less than 1 because we're getting smaller from the pre-image to the image. Over here, we have points A, B, and C, and the coordinates are given. And what we need to do here is we need to find and plot the image points of these points after they are dilated by a scale factor of 2 centered at the origin. So this O you see here is the origin, and that's our center of dilation. So I'm going to use the same idea that we discussed before. Since our scale factor, our K, is greater than 1, we are making bigger distances from the center of dilation. So what I'm going to do is I'm going to count the distance from the center of dilation to each of the pre-image points, and then I'm going to double that distance in order to dilate by a scale factor of 2. So from the center of dilation to point B, that's 1, 2, 3, 4 units from the center of dilation. So I'm going to move it 1, 2, 3, another 4 units. And that's B prime. It is double the distance from the center of dilation that the original point B was. And the coordinates here are -1, 2, 3, 4, 5, 6, 7, 8, 0. Now for point A, counting from the center of dilation, point A is 2 units up. 2 units up. So I'm going to move it another 2 units up to double the distance that the original point was from the center of dilation. And now we have our image point of point A, which has the coordinates 0, 4. And finally, we have point C, counting from the center of dilation, 1, 2, 3 to the right, 1, 2, 3, 4 up. So I'm going to move it another 1, 2, 3 to the right, 1, 2, 3, 4 up. And I have my point C prime. It is double the distance from the origin as the original point C was. And the coordinates 6, 8. So as you can see here, to get from each of the pre-image points to the image points, the coordinates were multiplied by the scale factor. 0 times 2 is 0. 2 times 2 is 4. -4 times 2 is -8. 0 times 2 is 0. 3 times 2 is 6. 4 times 2 is 8. So that's a really great rule that we have when we're dilating centered at the origin, that we can just take each of the points, both the x and y coordinate in the pre-image, and multiply by the scale factor to get the image point. Once again, that only holds when your dilation is centered at the origin. Another thing that I do want to point out is notice how the center of dilation, each pre-image point, and its image point are located along the same line. That's something that's going to come in handy later. The next part of the question here says, how can you verify that C prime is twice the distance from the origin as C was? Well, we're not going to do it on this video, but what formula could you use if you want to verify that it's the same distance? Sorry, that it's double the distance. You could use either the distance formula or the Pythagorean theorem. You can find the length that the original point C was from the center of dilation, and you can find the length that the image point C prime is from the center of dilation. And you can compare, and you should see that this distance is double the original distance. The last thing that we're going to see in this video is this example over here. We have segment AB, and we need to dilate this segment by a scale factor of 3 with a center at the origin. So we do know that if our dilation is centered at the origin, that we could take each of our points and we could multiply them by the scale factor. A prime, A prime would have the coordinates -1 times 3 is -3, 4 times 3 is 12, and B prime would have the coordinates 12, 6. And I'm going to plot those as well. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6. Here is our dilated line segment. And notice that by moving it triple the distance from the center of dilation as the original points were, we actually increased the size of this line segment. So if you triple the distance away from the center of dilation that the point is, it actually will increase the size of the entire line segment. Part B says to find the slopes of AB and A prime B prime. You could use slope formula, but since I have these graphed on a grid, I'm going to count rise over run. And notice how these are decreasing lines, so they are going to have a negative slope. So I'm going to count up for my rise, 1, 2, and over for my run, 1, 2, 3, 4, 5. So I'm going to put a negative because it is a decreasing line. The slope is -2 over 5. I'm going to do the same thing over here. 1, 2, 3, 4, 5, 6 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And notice that if we divide top and bottom by 3, -6 over 15 reduces to -2 over 5. So we see here that both of the line segments, the pre-image and the image after the dilation, have the same slopes. And this tells us something important about them. This tells us that they are parallel to each other. And that's an important property of dilations. Dilations preserve parallelism. In the next part, it does say to find the lengths of AB and A prime B prime in simplest radical form. You can either use the distance formula or the Pythagorean theorem in order to do that. Since I do have a grid, I'm just going to use the Pythagorean theorem. I'm going to close these up over here. Oops, I connected that back. And that is 2. This is 1, 2, 3, 4, 5. So I have 2 squared plus 5 squared is equal to c squared. So that's 4 plus 25. So I have 29 is equal to c squared. So c is equal to radical 29. Let me check out the next one, and I'll simplify radicals a little bit later on. I'm going to form a right triangle again, because once again, I want to use the Pythagorean theorem, but you can very well use distance formula here instead. I just have a grid, so Pythagorean theorem is easier for me. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's 6 squared plus 15 squared is equal to c squared, which is 36, plus 225 is equal to c squared. So we have 261 is equal to c squared. C is equal to radical 261. If we simplify this radical 261, it simplifies to 3 radical 29. And as we can see here, the pre-image length is radical 29, while the image length is 3 radical 29. So as we can see here, the original length was multiplied by 3, and that does verify what we learned about dilations previously, that if you move the points away from the center of dilation, that the figure will get bigger. And since we tripled the distance from the pre-image points and the center of dilation to get the image points, we actually tripled the size of the line segments as well.